In this video, we're going to go over exponential functions and relative rates of change. It's going to be really short and simple, all right? And because we've already gone over this essentially, but I just want to go over two examples really. So remember, whenever you talk about exponential functions and relative rates of change, you're always thinking about functions that look like this. P of t equals p0 times e to the rt. And that r, of course, is the relative rate of change. And the p0 is just the initial value. So let's say you have this example where they give you the relative decay rate. Okay, it's 3.9% per second. If you start out with 5, then how much are you going to have at time t? So you know that the function has to look like this, equals p0 e to the rt. What's the r? Well, it's decay. It's a relative decay rate, so r has to be negative. So r is actually negative 0.039, and the initial value is, well, p0 is just 5, because that's what they told us. So the function should look like this: 5 times e to the negative 0.039 times t. And that's it. Okay, so that's how you write down the exponential function if you're given the initial value and the relative rate of change. Of course, if they give you a relative growth rate, if the relative rate of change is a relative growth rate, then instead of r being negative, it's going to be positive. That's the only difference. Okay, the initial value is again 5, so p0 is going to be 5, and r is going to be 0. So that's positive 0.039, and therefore the exponential function is going to look like 5 times e to the 0.039 times t. And that's it.